Hello everyone, and welcome to this tutorial video where I'm going to be showing you how to build a tracked vehicle, how to make a microcontroller to operate the tracks, and some little tips and key information that should hopefully help you. So let's begin. This video is intended for beginners because it has some fundamental principles that most intermediate users will probably already know, but pretty much there are tank tracks in the game, or tank wheels as they call them. And you can see this one here, which is a drive wheel, and then we got two here that are just kind of circular, almost like pulleys, whereas this one here has the chain, or pulls the chain. The microcontroller that we'll be building will allow you to operate it in forward motion, turn it as you're driving, and when you come to a complete stop, you'll be able to rotate in place. So just like this, where we're spinning around. So we're not using momentum, we're just rotating in the regular spot we're sitting in. The exact same principle actually can be applied to skid steer style vehicles. So the exact same microcontroller is operating this. You'll notice the wheels are not turning, but we're still getting that change of direction. And of course you can spin around in the spot very quickly even, but it is the exact same microcontroller and principle as the tracked vehicles. In the workbench, the first thing I'll do is turn on the symmetry and build kind of a platform. Now, of course, I'm not going to be showing you how to build a beautiful tank or tracked vehicle, but just basically how to work the systems. Now, if you type in tank, you'll get the tank drive wheels and you'll get the tank wheels. Like I said, the tank drive wheels are the ones that have the RPS connection input. The tank wheels are sort of like idlers in a car, and all they do is just have the tank track kind of spin around it rather than actually inputting power to it. Now, keep in mind, you could build your creation fully out of the drive wheels and it'll still work. Meaning, if you just put, say, power to one of these, you can have ones that don't have any power going to them, or you can choose to use one of the small wheels. I like the combination of the look, so definitely that's up to you. But one thing you have to do is take careful note of the orientation of all the arrows. You saw me kind of rotating things around. That's super important because the rotation will play a factor. The way the game works is when you have, say, these track wheels in the same direction like this, and these ones in the same direction like this, you spawn it, it will automatically form the track that goes around it, okay, on both sides. Now, if I were to put one in an incorrect orientation with, say, the up arrow up like this, and just for good measure, let's put this one in the right direction. So here, we'll rotate it and orientate it such that it is matching with those. You could see there that arrow is not matching the plus direction side, so we have to go and rotate it like this. Now that is matching. So what we should get is this side, let's call it the green side, should have the track working, whereas the red side will not have the track working. Okay, so look at that. Here, that one is not being used. Over here, it is being used. So keep in mind, you have to orientate those arrows in the same directions in order for it to recognize that it's part of the same tracked system, okay? Now, over here, now they're all matching in the same direction, so everything should work. In theory, we spawn it in, both sides you see have the track now. You also cannot mix and match sizes, even if they are the arrows are pointing in the same direction. So in that case, that does not work. They have to be the same size track, whether it is the drive wheel or the non-drive wheel, but they have to be the same directions and they have to have the same size. And I think it goes without saying they have to be on the same plane. So in this case, this wheel normally should be in there, whereas now it's not, and of course the track does not recognize it. Once you've positioned the tank tracks in the locations that you want, then of course I'll leave it up to you to do the creative design. I'm not showing you that in this video, but I will show you how to make this system work. Now, my recommendation is to always make this either electric or diesel electric. And the reason for that is it's much easier to regulate and control the power coming out through these guys into there and there than running a series of clutches and gears. But that's still possible. I actually did a direct diesel drive on my amphibious Sealander, so it is possible, but the purpose of this video is to get the principle going for you, and you can apply this then to the direct drive versions if you also want. Keep in mind, the idea behind these tank tracks is that at a given time, you can have both the green side and the yellow side, let's say, moving forward in the arrow direction. But in a moment's notice, say you want to turn, then you'll have this side being forward, the green side, and yellow being backward or not at all. It'll stop giving power, and then you'll have the thing turn. So for that reason, it's just easier to show the concept with the electric motors. But yes, if you have a big enough engine, and if you have some clutches, then you can apply the exact same principle I'm going to show you here. In essence, rather than us cutting power in the microcontroller to the engine here, to the motor here, you would just cut power to the clutch and have it turn. Anyway, so this is kind of fundamentally what we're going to be doing. So of course, we'll throw in a battery and we'll throw in a seat. Now this is going to be purely an electric vehicle, but the same principle will apply to, you know, if you have a diesel electric, you're using this system plus adding a generator that can hopefully keep up with the power used up by these motors. What we'll need to do is plug everything into the battery, whether you're using a relay or breaker, but for this video, I'm just going to show you basic. And then we'll need to spawn our empty microcontroller. And with that, we can get to work. The first thing I do inside here is start off with the nodes that we know we'll need. So we will need a couple of different things. So firstly, we'll need the number output, which will be our left motor. And then we'll need the right motor. Definitely need to spell that right. And this will be both number outputs. So with those number outputs, that's what's going to be going to these and these. So left, left, right, right. Here you have a choice now whether you want to connect the seat to the microcontroller with the AD axis 1 and axis 2 WS by making these style connections, or you can use the composite channel. You could see here value 1 is AD, value 2 is WS. For the simplicity of this video, since it's considered more basic, I'm just going to roll with the numbers, but keep in mind it's pretty much the same to do it with the seat. Now we need inputs here, so we are going to need our throttle, which is going to be our WS, and then we need our steering, which is our AD. So that's kind of how you can define it, so it's easy for you to use. With these already now, you can pop into the logic, and I always sort them out based on where the nodes are. So in these nodes here, these nodes here. And now we pretty much have to play connection in here. So the first thing that's pretty much quite straightforward and easy to note is obviously you can put forward throttle directly to these and your creation will move. So if we just try this out in a very rudimentary sense, so throttle is WS, steering is AD, spawn this thing in, we should now be able to give it forward power. Okay, we're going forward, I'm just holding W. I can stop it by holding S, I could keep holding S, it starts moving backwards. Of course, I cannot steer because I didn't plug any of that in, but that's just basically showing you that this is a working system just basically by adding the throttle to the motors. But this is now where it gets a little bit more tricky. So what we'll need to do is have our steering dictate the motors. So what I do is I use a threshold function, and you'll apply that here to your steering. So we'll plug both of these in here and here. You could hold control to select multiple things, by the way, so I'm holding control now, letting go, and letting go. So here we'll set the positive side, so with a low of 0.1 and a high of 1, and here the high will be negative 0.1 because it's greater than negative 1. So we've now set our threshold functions, and we can now use them in a numerical switch box. Now, numerical switch boxes are very useful functions. They allow us to switch values on and off through these channels using this switch signal. So pretty much you can plug in your threshold gates to the switch signal, and that will now put through the first value, which is the on value, and not put the second value if this is on. At this point now, what we do is we can plug in our throttle value to the off position. And there's a couple of different ways of doing this, but keep in mind, if we've now plugged the throttle in to the off position, that means that if we are purely, going in a forward direction, meaning you're not steering at anything, it's simply just coming out the other side. Now here, we'll plug in these values here and these values here. So we'll see if it works, and if not, we can reverse it once we test it out. There's no reason to break your head over it, but pretty much now we end up with the same thing. So we're gaining forward motion unless you're steering in one direction. Now, if you're steering in this one direction, it will activate this switch signal and go on, which is 0. So keep in mind, if you don't put anything, it's purely 0. So we can test that out in the game. I'm just holding W. Now if I start holding A, we start to turn left. So that seems to work. If we start to hold D, it's going to start to turn the other way. Now there's a bit of a delay. So what you will want to do is on your seat, set the A and D function, the steering at least, to a 100% reset sensitivity, because then it will interact immediately. Now I also do the throttle also to 100% reset, and now it should just be a little bit more spiffy. So we gained a little bit more power here, and I'm turning instantaneously and turning instantaneously. So it seems to be working properly now. Now just to show you that you can use all the ones with the sort of spikes, it will work in the exact same way. Now because the creation is so light, you see that it's kind of pulling to one side. It shouldn't be pulling to any side. It should be going quite straight. So hopefully that resolves itself. I've always had that resolve itself after just adding a bit more things to it. As you can see, added some more weight, and now we're just kind of going quite straight and nice. So that is going to be a problem if you're just using very, very light creations. And also possibly if the batteries are struggling, if you're not reaching your full potential in your tracks, if you have one set to be less grip or less tension or whatever. So there's a couple of different ways that you'll find, but I think the most part is that it should register and go quite straight. But the idea is now that we're able to turn, so me holding D, we're turning left. Me holding A, we're turning right. Now we can start going backwards, and you could hold D and do this, and A and do this, but what you can't do is spin around on the spot. I'm sitting here, I'm holding A, nothing's happening, I'm not spinning. So that is the next step. But if this is all you wanted, and not to have it kind of spin on the spot, then you're done. But we're not done. So we're gonna hop in here and change some things in this microcontroller. Also, I noticed that we didn't adjust it, so we're just going to call this the track MC. And here, eventually, we will need one thing potentially, but we can also leave it as it is. The one thing I'm talking about is if you do want to have a button for reverse, as I like to have. I don't like to have just holding W, holding S, working my actual working my forward and back motion. I prefer to have a button to toggle my reverse, but if that's not a problem for you, then you have nothing to worry about. It's quite simple. If you put the reverse button here, you'd obviously put it in your creation, and in here all you would do is make your throttle clamped. The throttle would not do anything past 1, and then when you turn on your reverse button here, then it would go through the on switch and create a function with a -1. So it would just be a very simple reversal of what we're trying to do here. So you'd have your throttle going here, throttle going here, and then this one going here with a -x. And then this goes to everything else here and here, and this comes your reverse button. But we're not focusing on that here, so we'll just leave it as it is. Now, next we need to do, like I said, is make it rotate in place. So to have it rotate in place, we have to have two things happen. We have to have us be stopped, okay? And the second thing we do is we have to be trying to turn. So currently, we're only activating the steering if we are also moving. But we now want to do it such that we are not. So what I do is I take this threshold, I'll just make a copy of it down here, and I'll make a low of -0.1 and a high of 0.1. So that's pretty much in between these. So here, these are if you're trying to steer, whereas here now, we're attaching it to the throttle function, meaning our throttle is nor forward nor back. So it's 0 or close to 0. Now you could set this to 0 exactly, but then you'll have a very fine margin, and I don't recommend that. So having it a little flexible like this is definitely better. So what I do is I'll drag this away just so we can have a little bit more space to work between our various things happening here. So now we need an AND function. And the reason for this is because now we have to track what you're trying to do. So if you are obviously in motion, you can do this and it's going to steer as it has been. But if you're stopped or not putting in throttle, then we'll have the first part of the AND function. So that's the first thing. So say you're not putting in throttle, and in addition not putting in throttle, you're trying to turn. So either you're turning here or you're turning here. So based on those, now these functions ring true. So with this AND function now ringing true, it has to go to a new set of numerical switch boxes. So you'll learn to love the numerical switch boxes if you don't already. They're very useful and very good. So what we'll first do is we'll take this switched value and go purely through the off path. So off, off, and here. Same thing here. So off, off, and here. So the idea is, even if you don't do anything with these guys, you'll still be getting your right and left motor to push you forward and to steer you. So those are things that will come no matter what. You can even test it out in the game, so your thing should still be working identical to how it was previously, with the exception of you still can't turn left and right, so you can only turn when you're in motion. But we're about to change that. So we'll head back in, and pretty much what you'll need to do is the following. You'll need to have this function here and here. This AND function here and here. So this kind of jumping back and forth is intended to have a certain different sort of forward motion or backward motion to the left and right motors based on what you're trying to do. So if you are sitting in spot and trying to turn left, you got to have your right tracks pushing forward, your left tracks pushing backward. So that's what this all is. And then one thing that I learned in my recent video making the front loader is to put a reduction factor now, better than trying to deal with it after. So we'll put this and we'll call this throttle or spinning throttle, spin throttle reduction. And we'll have it between 0 and 1 with a rounding of 0.1 and a value of, let's say, 0.6. So that is our spin, or not reduction, but factor, because we're applying this factor and we're applying it to our spinning. Next, you will need a constant number, and that constant number is 1. So you don't have to do the spin throttle reduction, but you need to do the 1 constant. And now we'll apply a function and that function will go here, and it will be negative x. So that reverses the direction that we're trying to do. Now, because we have our spin throttle reduction, we will now multiply that here with the 1, so that just reduces the throttle we're putting, and then we'll go into here with the negative x. So now here we have whatever is reduced in the positive direction, here we have whatever is reduced in the negative direction. So with the rest of the microcontroller, we're going to take the reduced positive, apply it here and here. We'll take the reduced negative, apply it here and here. Now in the game, I'm turning left, holding A. Now if I come to a stop, I hold A. Well, we're spinning in the wrong direction. So how do we troubleshoot that? You simply go back into your microcontroller, and clearly the location of the switches was not good. So whatever I put here as negative should now go to this, and whatever I put as the positive should go to the on and the other on. Back in the game, driving, holding D, we're turning left or right. Now I come to stop, hold D, we're spinning right. So hold A, we're spinning left. Forward motion, we start to move. So now we have fully a system where we can turn, steer, stop, rotate. Now keep in mind, the one thing that is a little funky is if you're holding S, it goes backwards. If you hold A and S, you kind of turn to the back and left. But if you are going this and holding A, but come to a stop, it starts to spin in the other direction. You see here, we're kind of going there, and then we come to stop, we're going there. Remember how I talked about having a reverse button? Well, if you had a reverse button, you can actually fix this quite simply, but because we don't have a reverse button, it's stuck to our pretty much threshold gates telling us that we're not moving forward, so it's going to start rotating in the direction we are pressing A or D. So that is something you're kind of stuck with, unfortunately, but it's not too bad. You kind of get used to it. If you did use a reverse button, then you'd plug your reverse button here into this simple equation. So we have a numerical switch box, we have a constant number -1, a constant number 1. The -1 is on the on, the positive one is on the off, and you multiply it. Now remember, your reverse would go here, so this tells the controller you're in reverse, and then you multiply this with your factor, and you pretty much splice it in to where your constant number of 1 was going, and then it will reverse the signal and the direction of these numerical switch box values, and then you'll actually end up with a much smoother reverse motion. But because we're not using a reverse button, then we're just using this. In my loaders here, I've actually done that. So if I put it in forward gear, drive, I'm spinning right by holding D. If I put it in reverse, I hold D and I spin left, because if I'm applying backward throttle and pressing D, I want to spin in the same direction I'm going. So that's why I do use a forward and back gear with a button, but that's up to you. So thank you all for watching. Hopefully you learned something when it came to tracked vehicles, how to make a simple microcontroller, how to make them actually function and work. Hope you enjoyed the content. Stay tuned for more videos. Stay tuned for more creations. Thank you to all of my YouTube members, to my Discord server boosters, and to all of my fans in general. We'll see you next time.